Okay, so machine learning systems can be classified according to the amount and type of supervision that they get during training. Okay, so um, in general, machine learning can be classified into supervised or unsupervised na learning. The supervised na learning can be further classified into classification or regression, and the unsupervised learning can make use of clustering. So let's proceed to discussing what supervised learning is first. So in this kind of learning, supervised, the goal is to predict a certain value of an outcome or response or label based on a set of data set na features. Okay, so we have a training data in which we observe a label na y. Okay, so using this data, we will identify the task, build a model for that task, and build a prediction model or learner, which will enable us to predict the outcome or the label for new unseen objects. So we say that a model is good if it can accurately predict a certain outcome. Okay, so that's why it is also important that we know which appropriate na performance measures to use. Okay, so this is called supervised because of the presence of the label, na y, to guide the learning the process. So to put it simply, consider, say when you are teaching a child the difference between the dog and a bird. So you say that to a child that it is the dog because it has four legs compared to a bird which has feathers, right? And it can fly, and dogs cannot. So you identify or teach the kid the names of the dogs as long as the features of the dog versus the name of the bird and the features of the bird. Okay, so consider this more concrete example. So we have a data consisting of n samples. So in this case, we have 5 samples, and each na sample or a person has associated na features or attributes. So in this case, a person have a recorded na features such as age, a history of hypertension, heart disease, or ever been married, glucose level, as well as the BMI. Okay, so, and each sample has also associated the label or outcome. So in this case, the label is the stroke, so which should either be 0 or 1. So in other words, if 1, meaning a certain person has an experience of having a stroke, and 0 if that person has not had a stroke. Okay, so for instance, if a person is, let's say, 67 with no history of hypertension but has heart disease ever been married with glucose level of 228.69 and BMI 36.6, has had an experience of stroke. Okay, so the job of your machine learning model is to create a mapping or a relationship in between your features as well as your label. So we consider this as supervised because there is an associated na label and the model can learn from this label. So the label na y, this label y, can either be categorical or nominal. So in this example, the label y sub I, this one, label, which is stroke, can be categorized into 0 or 1, where 1 indicates a stroke and 0 otherwise. Since we are categorizing a certain sample or a certain person, whether they had experience having a stroke or not, we consider this as a classification na task. Okay. Another example. Suppose what we wanted to do is to predict whether a certain image or chest X-ray uh, of a person has COVID-19 or non-COVID-19. So each of this 3 images above are labeled with COVID-19, meaning these chest X-rays have been annotated or been identified by doctors as having COVID-19. And while the bottom, or the pictures at the bottom, are chest X-rays that have been labeled as non-COVID-19. So after training this model, we have a new chest X-ray image. So given its image, what would be its label? So the the label of this new X-ray can be classified as either COVID-19 or non-COVID-19. So in other words, we are categorizing a certain sample into several categories. Yeah, obviously. So anyway, what if we want to predict how long a certain person has been infected with COVID? So this is just an assumption, huh? This is just this data was just added for the sake of discussion. Okay, so suppose we have this images of chest X-rays that have been tagged with COVID-19 and images of non-COVID-19. So each of the image has an associated label, which in this one, this has been infected for 7 days. This person's chest X-ray, this person has been infected for 10 days. This person has been infected with 12 days. And for those with no COVID-19, have not been infected yet. So given a new chest X-ray, let's say how many days has been this person been infected with COVID. So instead of categorizing the chest X-ray into COVID-19 or non-COVID-19, the machine learning model will determine the number of days a certain person has been infected with COVID based on the chest X-ray. Here, what the model produces is a real valued number. So this is an example of a regression problem. Okay. So again, here's another example. So this is the fish eye, and fish eye is a local application, underwater application, which can generate automated data for fish count, fish identification, fish population density, fish length, and the fish biomass. So which of the tasks are considered as classification and regression? So fish count, fish population density, fish length, and fish biomass are all regression because they are producing a certain number or a certain value. The fish identification, on the other hand, is considered as classification because you are categorizing a certain fish into a certain species or a certain fish na ID. Okay,